Camera trap image classification using deep learning on edge devices, an artificial intelligence and IoT project. According to a 2019 United Nations report, up to 75% of the Earth's land has been significantly altered by humans. This has had the largest impact on wildlife. Indeed, up to 1 million animals and species are endangered and at the risk of getting extinct. Our world is currently facing a biodiversity loss crisis. Wildlife biologists and ecologists have ventured into several measures to study and protect endangered animal populations. One such approach is the use of camera traps, devices that record the presence of animals. However, even though these camera traps provide a suitable solution to monitor animals, they often generate an abundant amount of images that the ecologists must go through and classify manually. This is a tedious and time-consuming process. Furthermore, the camera traps are placed in remote areas, so results can only be seen after long periods of time. To solve these problems, we propose a system that makes use of deep learning and convolutional neural networks to automatically classify images. The data used to train the models was provided by Emirates Nature WWF, and after filtering the data set consisted of 1,000 images of each class: donkey, fox, and ghost. After testing a number of convolutional neural network architectures, the best results were obtained from a model called Inception v3, which gave us an accuracy of 94%. The results of this testing phase are highlighted in this table. The Inception v3 model was then used as part of a system that ecologists can use to automate the classification process, thus reducing the time wasted on manually classifying the images.
To demonstrate the system, we will first input some sample images. This can be done by clicking the Browse button. Once the file selector window appears, we can select one or more images based on our requirement. These images can be previewed in the left panel. The next step would be to click the Classify button, which passes these images into our image classification model. This model will then generate predictions for the animal in each image. These results can then be exported either in the form of a text file or as different folders based on the different animals. To verify the classification, the user can enter one of the folders, in this case the fox folder, and view the images it contains, which are indeed of foxes.
In order to solve the second problem and allow ecologists instant information when an animal is spotted, we deployed this deep learning model on edge devices such as the Raspberry Pi 4 and the NVIDIA Jetson Nano before comparing their performance. The table shows the comparison between inference times. Furthermore, the peak and idle power consumption of the devices were measured as shown in the graph. These edge devices were then used as part of a wider architecture to perform instantaneous classification as follows. As an animal passes by, the camera trap is triggered and captures an image of this animal. This image is stored on a Wi-Fi enabled SD card which allows it to reach the edge device. The classification is made on the device, and the labeled image is stored locally, while the label, timestamp, and camera ID are sent via the internet to a cloud database. On updating of this database, the ecologist's mobile application displays the latest animal spotting, only about 8.5 seconds after the image is captured. The following is a demonstration of our animal classification system. An ecologist opens the animal monitoring application. He notices the last animal spotted was a donkey in Galila. Meanwhile, many kilometers away in the Kab Valley, a camera trap is overlooking the peaceful night scene. Suddenly a fox comes prowling, and triggers the camera trap, which captures a picture of him. This picture is sent to the edge device, where a classification is made. Suddenly the ecologist sees his app update, as the newest classification shows up. He may now wish to look at statistics of the animals spotted over the last 24 hours, where he can see the most spotted animal and the most active camera as well as a graph of the spotted animals.
With this project, our aim is to contribute in the fight against animal extinction, by helping today's ecologists in their ongoing efforts to study animal populations through camera trap imaging. We hope our project will inspire future projects, which harness the power of technology to help save our planet's precious ecosystems. Thank you for watching our video.